We've seen the ports that Trojan horses use, the common Trojan horses. Let's see the different types of Trojan horses. There are Trojan horses for so many things. You can hide a Trojan inside of VNC, or VNC could be the payload of a Trojan. You could hide it inside of HTTP and ICMP. You could have Trojans that hide inside of data documents, or you can hide data in a Trojan. It can go either way. Trojans can be destructive or just for remote control. We can have Trojans for HTTPS. We can have Trojans that make you a part of a botnet army. We can have Trojans that turn you into a proxy server. Trojans that give remote access. Trojans against FTP. Trojans meant to deface a website. Trojans meant to capture e-banking information, or to create Trojans, or to notify, or for mobile devices, or give us a command shell. Trojans all over the place. I mean, the bottom line of a Trojan horse is that it gives the attacker some kind of remote control. Typically interactive, doesn't have to be. It could be fully automated. So any way we can package this into something that on the outside looks harmless and is normal, but on the inside there is something inside that is malicious, that is a Trojan horse. Command shell Trojans. This allows us to use a command prompt to attack the target. So we have a Trojan server installed on the target, and it opens a port, and then the client is on the attacker, and we make the connection and we use it at the command prompt to launch, or we use it to launch a command prompt, a command shell, on the target. Defacement Trojans, of course, we're using that to edit or replace strings and bitmaps and logos and icons, especially against web servers. But you can do defacement against a variety of things. Web servers just have, of course, the maximum impact. So we can view and edit almost any kind of program, menu, dialog box, icon. And we could use our own custom application to say, deface Windows applications. We know that botnets are basically armies of infected thousands, hundreds of thousands. Large number of targets. So this is Aunt Lucy's machine and Uncle Ernie's machine. Across a large geographic area, they are all under a command and control center, often in a hierarchical fashion. So I'll have one major command and control with these local sort of like lieutenants, and then in all of these little regions, they talk to their local handler, which gets the major marching orders from up top. How do we do this? IRC was traditionally the common way. It doesn't have to be. It could be other ways. Just something where these intermediary things get the main command from you, and then the little ones go out and get it from their local handler. So we use the botnets mostly to launch massive denial of service, distributed denial of service, but it can also be for fraud and stealing financial information, or just defacing websites or other purposes. Actually, to be quite honest, a lot of botnets now are being used so that we can use their CPU power for Bitcoin mining as well, because it takes a lot of CPU power to mine or create Bitcoins. There are all sorts of botnet Trojans. There's Chewbacca, it's Tor-based. It has stolen, almost 50,000 payment cards from 45 retailers in 11 countries in just a 2-month span. There's Skynet and Cyberbase. Skynet is also Tor-powered, does distributed denial of service, Bitcoin mining, and stealing banking info. It's spread through Usenet. There's the Cybergate Remote Access Trojan, RAT, fully configurable, stable remote access, remote administration tool. And it is constantly being updated, and you can use it for all sorts of things, from routine maintenance to remotely monitoring children to capturing user activities and backing up your typed data automatically. But so while you can use them for benign purposes, for hackers, of course, it's not used benignly. There's a Trojan proxy is basically a standalone Trojan that we use to relay our attacks. So it's a hidden proxy server on a target. So Aunt Lucy is just doing her normal thing, but in the background, her machine is relaying malicious attacks. And so if they ever trace it back, they trace it to her, not us. So you can have thousands of computers on the internet infected with proxy servers. And there they are. Here's just one of them, Web Proxy Trojan Creator. It's a proxy server Trojan. You can have multiple connections from many clients. It gives IP addresses and ports by email to the Trojan owner. We can have FTP Trojans, so it will install an FTP server on a target so we can upload and download files. We can have VNC Trojans. So it starts a VNC server so that I can make a VNC connection. Now, if it is a hidden VNC viewer, I can just watch what the user's doing on their desktop. Now, the thing is, VNC is a legitimate normal utility that allows us to have remote control, so it's hard to detect that a VNC Trojan is actually malicious. There's another one called HesperBot. This is a banking Trojan, and it will keylog, it'll get screenshots, it'll capture video, and it'll configure remote proxies. It creates a hidden VNC server to connect to the target, like a bank teller's machine. The VNC does not log the user off the way RDP does, so the attacker can just be sitting there while the bank teller or the bank manager or whoever is doing their thing. There are Trojans for HTTP and HTTPS. It's basically we'll use these protocols to bypass firewalls because firewalls generally allow these protocols to go through. Then they can be executed on the Trojan runs on the internal host. And then what it does is it launches the Trojan to make a connection out past the company firewall to connect to you. It looks like just the user is doing normal surfing. So the firewall is going to allow it because you've got a command and control website waiting. But unless they know that your website is malicious, it just looks like the user is going out to a website. There are remote access Trojans, whether they're HTTP or not. So we can capture data, we can display stuff, we can play sounds, we can record data as it's happening. We can download and upload files. We can disable programs and system services, including antivirus. We could distribute our threats and flood internet connections. We can track browsing history, track activity. We can hijack their browser. And we can make fraudulent claims about spyware detection and removal. We can say, spyware found, click this. And then we only charge them $29.95 to remove. We can also have HTTPS with using SSL, and it's SHTTPD. This is a Trojan. It's a small HTTP server. You can hide it in any program. It's wrapped up into a legitimate program, and when it's executed, it turns the target into an invisible web server. Not that we want people to connect to a web server, but that's how we connect to it as the attacker. We can hide stuff inside of ICMP. We can do ICMP tunneling. So a covert channel is some method of hiding something inside something else so that it's undetectable. And one way to do it is through ICMP, because an ICMP ping has just a lot of space in the ping packet that's just filled with fluff, like a repeat alphabet or repeat numbers. So if we replace the fluff with an actual malicious piece of code or data, then we're hiding stuff inside ICMP. That's what we call ICMP tunneling. Of course, it means that you have to be able to send ICMP in or out or between the attacker and the attacked target. This allows one protocol to be carried over another protocol or just data to be hidden inside of an ICMP packet. It uses ICMP echo request and reply to carry the payload silently within that ICMP ping. So here's but one tool, ICMP send, that we can use. Loki is another one. Here's an example of ICMP tunneling. In Wireshark, we capture an ICMP echo request, and all of this stuff here could be something else, not just the ping. Remote access Trojans, they're just like remote desktop, like VNC. They give us a graphical interface of the target. And we can do it while the user is logged on, and the user won't even know. So they infect the target with some little tiny rat server. We then make a connection, or we have it configured to connect back to us. And it can be configured to connect on whatever port. And then that gives us complete control over the target computer. There are loads of rat Trojans here. Just a bunch of them here, loads and loads of them. ProRat, Optics Pro, Hellspy, Pandora, Dark Comet. They don't even necessarily have the term rat in the name. It's just one example, Adelair Web Remote Commander. And what's significant about it is it doesn't even install anything on the target. Here's another, the Hellraiser rat. Like so many rats, we have access to the target, send pictures, pop up chat messages, transfer files to and from, completely monitor what they are doing. Another one, the Covert Channel Trojan, CCTT, the Covert Channel Tunneling Tool. So it has a whole bunch of different exploitation techniques. We can have arbitrary data transfer channels. We can enable attackers to get an external server shell from within the internal network and from internal to external as well. We can do it over TCP, UDP, HTTP using POST and connect commands. We can have SSH, SMTP, POP, etc. So it's multi-featured, multi-protocol. An e-banking Trojan is specifically to intercept the target's banking account information, and we get it before it's encrypted, and we send it to the Trojan's command and control center. This is how we steal someone's credit card information. And that information is sent to us by email, IRC, FTP, other methods. So if we zoom in and look at this sort of picture on how this attack works. So first of all, I Trojanize some victim. They go to their bank thinking that they're logging in. The information is captured by this. It's sent to us, the hacker, by SMS or something. And then we, intercepting that, we can then use that information to do an unauthorized money transfer to the victim's bank. A variety of e-banking Trojans, TAN grabber, HTML injection, form grabber, all of these different ways that are specifically designed to grab banking details and banking login details. They might create fake forms. They'll get extra information. They might elicit out of the user card information, date of birth information. We can use them to impersonate and compromise the target's account. And we can use them to intercept and enter the customer number and personal access codes. A few others, Zeus and SpyEye, to steal bank and credit card info using FTP. We get other sensitive information as well. SpyEye will quickly initiate online transactions. And there's others, Citadel Builder, ICE9, and various ones. There's loads of them. Here's a destructive Trojan, Master Trojan. When executed, it destroys the operating system. It can format all local and network drives, and then, of course, the OS is completely useless, and they'll have to reinstall the OS. And so if we zoom in, you can see some of the features it has. You make a connection. You can do silly things like open and close the CD-ROM, but you can shut down, restart, log off. You can hide the taskbar, hide the clock, hide the start button, hide icons, swap the mouse, but you can kill processes, you can delete things, you can run a command prompt, you can open and close various processes here. So, and especially if you enable the registry editor, you can do some serious damage as well. You could have notification Trojans that just send the location of the target's IP to the attacker. So whenever the attacker, or whenever the target connects to the internet, the attacker gets a notification. We can have Trojans that hide data. And so they'll encrypt data files on the systems, the target system, making the information unusable. So that's like the first step in ransomware, isn't it? And then we demand a ransom, or we force the target to do something, make a purchase or something, to unlock the files. And the targets could be any file you like: database, personal information, files and folders, financial information, confidential documents, whatever we want. So that is a look at different Trojan types.